Bom dia mais uma vez a todos que já estão aqui. Vocês conseguem me escutar bem? Qualquer coisa, se tiver algum problema, fiquem à vontade para utilizar aqui o chat, tá? Então, primeiro eu vou fazer aqui uma introdução em português, mas eu gostaria de lembrá-los que esse webinar ele vai ser ministrado em inglês, né? Meu nome é Maiara, eu sou gerente de produtos da Nova Analítica, e nós estamos aqui organizando esse webinar que tem como título Como otimizar os seus protocolos de NGS e qPCR para SARS CoV-2 com os sistemas da Cytena. Então, nós temos aqui hoje o Christoph Niemöller. Ele é o especialista de aplicações da Cytena, né? Então, ele vai ministrar essa palestra. Eu espero que vocês possam aprender muito sobre os sistemas da Cytena. O Christoph, ele é PhD, com foco em genética, imunologia e biologia celular, da Universidade de Friburgo, né? Então, hoje ele vai apresentar um pouco os sistemas da Cytena com esse foco para NGS e para qPCR em SARS-CoV-2, tá? Então, antes da gente iniciar, eu gostaria de primeiro agradecer a vocês pela participação, agradecer ao Christoph, e queria passar alguns recadinhos para vocês. É importante que vocês fiquem até o final da apresentação para poder obter o certificado. E durante a apresentação, fiquem à vontade para colocar as perguntas conforme for surgindo aqui no chat. E nós vamos deixar para poder responder as perguntas no final, né, até para poder manter o fluxo da apresentação. E aí, no final, vocês podem perguntar em português aqui no chat, que eu vou traduzir as perguntas para o Christoph. Ok? Então, agora eu vou mudar aqui o idioma. Hello, Christoph. So, I did a small presentation now in Portuguese. And now you can start. You can share your screen, and I will pass the word to you. And I would like to thank you for this presentation. Thank you for your availability. And nice presentation to everybody.
Yeah, thank you for your kind introduction. My name is Christoph, as you may now know. And I'm working at Cytena, a small company in southern Germany, and we are part of the Selink Life Science Group. And I'm really happy to welcome you all to today's live webinar on automated non-contact bead-based DNA purification and low-volume dispensing for cost-effective SARS-CoV-2 sequencing, and also on qPCR on SARS-CoV-2. So today I will mainly focus on the two most relevant technologies from our portfolio, which can be used for efficient high-throughput COVID testing and sequencing. On one hand, this is the I.DOT, a low-volume liquid handler, and the other one is the C.WASH, a centrifugal plate washer that allows tip-free bead-based DNA purification. So as you all know, as you are all aware, there's a need for efficient COVID-19 testing. I will talk about that. Then I will talk about the I.DOT for non-contact low-volume liquid handling, the application of the I.DOT for COVID-19 qPCR testing, then the application of the I.DOT for SARS-CoV-2 sequencing, for library preparation, and then I will go into the C.WASH and talk about DNA purification, bead-based DNA purification for NGS library preparation. And finally, to sum it up, to show you an example, I will briefly talk about a paper recently published about automation and miniaturization of COVID sequencing, where the I.DOT has been successfully used. So I think you all know the global pandemic of COVID has had a tremendous impact on all aspects of the life of millions of people all over the world. And the numbers of the coronavirus disease are still increasing in many countries, for example, also in Brazil and in many other parts of the world. And Brazil has been hit hard by this pandemic, as you all know, and the numbers are still high. We still have to fight against this disease, and the fight is still going on. So there are many resources actually which are really important for this fight against COVID-19. One, of course, it's a well-educated staff in the hospitals who are fighting directly against this disease. Then it's well-equipped medical facilities, for example, oxygen supply, personal protective equipment is very important. But then, of course, today I want to focus on the importance of the diagnostic tools used for the fight against COVID and the equipment in the testing facilities, which both play a crucial role for the fight against this virus. So here I just want to show you the number of coronavirus tests performed so far in the most impacted countries around the world. And as you see, it's really incredible. It's 100 millions of tests have been performed so far. So this should just emphasize how important it is to efficiently, to develop efficient workflows for COVID-19 testing and for sequencing. So how would you basically perform a COVID-19 PCR testing? Here I show you just an example for a general workflow for COVID-19 testing. Of course, there's sample collection, then there's RNA extraction, and then a part which is really important is assay preparation, then real-time PCR and analysis, and real-time PCR, real-time qPCR and analysis is automated in most labs, of course, and easy to do. But assay preparation is labor intensive. It's usually prone to errors, and there is always a risk of contamination, and it's very time consuming. So this means there's a huge demand and also huge potential for the automation of assay preparation in COVID-19 testing. Now I just want to briefly introduce you to the I.DOT. The I.DOT is a liquid handler, liquid dispensing product we offer, platform we offer. It's non-contact. It's a non-contact dispensing technology without any need for pipetting tips. How does it work? The I.DOT basically has a source plate and a target plate. Target plate is then the plate where the assay is performed in, and the source plate is the plate which holds the reagents, the individual reagents. And the I.DOT now generates droplets in very small volumes of 8 to 50 nanoliters. And each channel of the source plate, which holds 96 wells, can produce up to 100 droplets per second. And this means that you can readily dispense microliter volumes to the target plate just by applying defined air pressure. It can dispense into any SBS plate, so 96, 384, 1536 is also possible. And as I already said, the I.DOT source well plate holds 96 different reagents. So this means you're not limited in the number of reagents or also templates you are using. So as I told you already, it can dispense from 96 wells into the target well plate. And this enables, of course, also very complex workflows. And another device we just launched this summer is the I.DOT Mini. This one only holds one source well plate for smaller, similar workflows, for example, for efficient dispensing of lysis buffer or similar applications. The very nice feature of the I.DOT is that it basically comes with its own control mechanisms for quality. So there's a quality detection or quality control mechanism. This is patented. It's called drop detection, and it's situated underneath the I.DOT one source plate. And this mechanism is actually counting every droplet which is released during dispensing, during the run of assay preparation. And it also automatically detects when a well accidentally runs empty, for example, when one forgot to fill it with liquid, with reagent, or if it contains bubbles. And after the dispensing is complete, it provides a color-coded map and a log file that really serves as a quality control. I will show you this in a minute. So how does the I.DOT pure plate look like? It's basically a polystyrol frame with polypropylene wells, and those wells are disposable and exchangeable. This means that you do not have to basically waste the whole plate if you're just using a few samples, few wells. You can just exchange them, which is very environmental friendly, of course. And there's the standard plate for 8 to 80 microliters, 8 nanoliters to 80 microliters, and there's a reservoir plate for 8 nanoliters to 500 microliters. And it comes with, or it can be equipped with different pore sizes. So this is just an example, a screenshot from the verification and sample tracking software from the I.DOT Assay Studio software. And here you can see that it really tells you exactly which well has been filled basically with the right amount of reagent, which can be really helpful for quality control. Now I just want to briefly show you an example how the I.DOT can simplify COVID-19 testing. Here I show you a typical reaction setup using the CDC SARS CoV-2 real-time PCR. And this real-time PCR actually requires 3 reactions per sample for the N1, N2, and RP targets. So this means if you want to screen 21 patient samples, this means that you have 24 samples, so 21 patient samples plus negative control plus positive control, and then times 3 for the targets, you end up with 72 wells. And for each of those wells, you would have to combine a master mix, separate sample, primers, probes, a reverse transcriptase, water. So this means that there are various components, small volumes down to 1 microliters, many samples. All this is very error prone, it's labor intensive, it's prone to contamination, of course, and it's time consuming. So this means that here the I.DOT really shines, it's accurate and precise, it's fast, and miniaturization is also possible. This means you can also scale down the workflows, the reaction volumes, which means that you also save a lot of costs additionally. This is how the target layout would look like in this case. So the software comes with a nice color code, and it really shows you which well is composed with which components. And here you have a nice overview of those samples, those reaction setups. And of course, you can achieve all different combinations of reagents and templates with these. Here's another screenshot from the Assay Studio software. And here you can also see now on the left-hand side is the source plate layout with all the reagents, and with the template you can of course also have different plates for the template and for the reagents to further decrease the risk of contamination. And then it also comes with a simulation mode, and it tells you exactly how long it would take to dispense all the volumes. And in this case, for this complete reaction setup, it would take only 4 minutes and 36 seconds to dispense this whole plate. Next, I would like to talk about SARS-CoV-2 sequencing. So SARS-CoV-2 sequencing is, of course, absolutely crucial for the phylogenetic reconstruction of the viral spread. and the evolution of the diseases or the disease in various countries, and is of course also very crucial for the identification of newly emerged variants of concerns. As you all know, the Delta variant is currently spreading in many countries around the world, and the numbers are again increasing due to the Delta variant. So it's really important to detect those variants as early as possible to be still able to confine them. And this is why it's important to have very streamlined workflows for COVID-19 sequencing, for SARS-CoV-2 sequencing. And here I just want to give you another example of how the I.DOT can simplify this. Usually, next generation sequencing runs or samples are indexed prior to sequencing, especially if you have a lot of samples to sequence. And this here is an example how to, by combinatorial indexing, how to achieve indexing of 384 samples with ease from a source plate, which holds basically 12 and 16, 24 forward and 16 reverse index primers. And this indexing here is performed in just 3 minutes and 21 seconds. So very fast, very accurate. And of course, here you also have the possibility to downscale and to save money and reagents. And that's not all, of course. You can have more indices per well. So this means you can, in theory, index more than 2,300 individual samples just with 96 indices. So this is very powerful. Another application is, I just want to briefly mention this, is rapid normalization of cDNA libraries using the I.DOT. So what you would typically do here is you, after, for example, cDNA generation, you end up with various samples, all different in DNA concentration. You can load them to the source plate, dispense them into a plate where you measure DNA concentration, for example, using picogreen, the picogreen assay. You read out the standard curve and the individual samples, and you would calculate a standard curve and then calculate a concentration table. And this can be then used in the I.DOT again to normalize your DNA samples in the next step. So next, I would like to introduce you to the C.WASH, which is an instrument that we just launched a few months ago. A C.WASH is an instrument for washing microwell plates using centrifugal forces, and it can basically remove liquids from well plates without the need for pipette tips. And this enables tipless and non-contact washing, for example, of cells or of ELISA plates, and of course also for DNA purification, bead-based DNA purification. And today I, of course, want to focus on this. And in contrast to other plate washers, this results in a higher reproducibility, reduced cost, and faster processing times. So now I just want to focus on DNA purification using beads. The C.WASH comes with a magnetic plate holder seen here on the left, and it can basically attract the beads you're having in the mixture of the DNA sample, and by that purify the beads. If you're not familiar with bead cleanup, I just want to briefly mention this. A sample is mixed with PEG and with the beads and with sodium chloride. Those are the main three important components. And then the DNA is binding to those beads. And in the next step, the beads are pulled down by a magnet, and they can be washed with using ethanol and then they can be really well washed and be sequenced on a sequencer in the next steps, in the downstream steps. And using beads to clean up DNA really has become the gold standard for a next generation library preparation. This has become really important. And although it is really actually rather quick when compared to column-based methods, it becomes more and more labor intensive since it's meant for high throughput, and it's really, really helpful for high throughput applications. And thus there's really a need for efficient and optimized workflows and devices for bead cleanup. So how does the C.WASH work? You would basically put your plate on the C.WASH table holder, and the plate is then pulled in the device, and the plate is then, of course, the magnet attracts the beads. The plate is spun up and the liquid is thus removed from the plates. And then the next nice feature of course of the I.DOT, it then automatically adds the washing buffer, in this case ethanol, to the wells, and this cycle can be repeated. And what's also really nice about this instrument, you have complete free choice. For example, how fast you want to spin, how many washing cycles you want to do. So you can write protocols, you can write your own custom protocols for your application. So it's completely customizable. Here, just want to briefly show you a comparison we did of manual washing, manual bead cleanup versus the C.WASH. And what you see is that we basically washed or purified an NGS library using manual pipetting and the C.WASH. And for manual pipetting, it took around 25 minutes, and around 300 pipettes had been used for this. So a lot of waste is generated during bead cleanup, and the I.DOT is doing the same tasks in 5 minutes without any pipettes required. And the results are shown on the right-hand side in the bioanalyzer profiles. So it really generates very well, very nice profiles, and yeah, it's really a comparable or even better profiles to manual washing. This is what we actually also see when we really repeat the assays. We see that we have a reduced standard deviation in DNA recovery, and so it's really reproducible. Here, just want to give you a brief overview over the portfolio we offer. So we not only offer liquid dispensers and the C.WASH, but also single cell isolation devices for single cell printing. I don't want to go into detail here, but we basically offer a whole workflow, devices for a whole workflow for next generation library preparation with the I.DOT, the C.WASH, and this enables really a nice automation and cost reduction. So no pipette tips for both devices, significant reduction of costs by assay miniaturization. We achieved up to 20-fold reduction of reagent consumption using the I.DOT. And of course, this also enables an increased throughput due to this automation and a highly parallel processing in 96 or in 384 well plates. And we now also offer Segway Kits. Those kits are for next generation sequencing library preparation for genomic DNA, for COVID sequencing, and also for single cell applications. So last but not least, I just want to show you a bit data from a paper recently published in Nature Communication by the group of Nicola Crosetto at the Karolinska Institute in Sweden. And he published a cost-effective workflow for mass-scale SARS CoV-2 sequencing using the I.DOT, and it's called CoV-seq. This is basically the workflow he used. So first he did first-run synthesis and CDC multiplex PCR on the RNA using the I.DOT, automized and miniaturized, then DNA purification, manual DNA purification in this case, then DNA digestion and ligation of COV-seq adapters. So basically the barcoding step here again, he used the I.DOT for this. Well, they used the I.DOT for this, then again DNA purification, which was then followed by in vitro transcription pooling, RNA purification, another round of adapter ligation, reverse transcription, and library PCR and purification. And this is really a prime example of how a workflow can benefit from automation and in terms of cost reduction and increase of throughput while maintaining really a high level of data quality. And he did not yet use the C.WASH, but what I just want to briefly show you here, of course, those DNA purification steps could be replaced by using automated C.WASH workflows. Here I have some data from the paper. So it's really interesting. I highly recommend it. He showed really high concurrence of the SNPs he detected, or they detected, by when they compared NEB-NEXT versus COV-seq, around 95%, which is of course very important for the surveillance of the virus for phylogenetic reconstruction. And he also achieved near complete coverage of the SARS CoV-2 genome using the two restriction enzyme digest, which is basically the standard protocol they show. And what's also very interesting, what also highlights the power of the I.DOT, they could show a significant reduction of costs, and this of course also enables upscale or downscaling and upscaling of throughput, in this case of library preparation. So it's less than half the costs when compared to NEB-NEXT, for example, or Nextera per reactions. If you process 1,000 samples, and it becomes even more apparent if you process 10,000 samples, it's 20% or maybe 30% of the costs. So with this, I would like to close my presentation, and I'm really happy to have so many guests here in this presentation, and I'm welcome to answer your questions.
So thank you so much, Christoph. I mean, it's clear that these systems can make these protocols like sequencing and PCR very much faster and easier and automated. And the results are more reproducible. It's less work, less pipette steps.
Yeah,
so
exactly.
yeah, they are very interesting. So I'd like to know if someone has questions. You can put it here in the chat. Agora mudando para português, fiquem à vontade para colocar as perguntas aqui no chat. Someone is typing. Very good presentation. No questions from my side.
Thank you. I would love to hear more Portuguese because I love the language. I cannot speak it though.
Depois eu posso falar mais em português. I can speak more in Portuguese after. So, José Antonio is asking how much it costs, the whole system.
I cannot tell you, to be honest, so not today, because I'm not a sales person, but I can also, of course, give you the contact of our sales team, and they will give you a nice offer.
Yes, so I can answer that. Olá, José. Você pode entrar em contato comigo, eu vou deixar o meu e-mail aqui disponível, tá? E aí a gente pode passar um orçamento, passar, né, uma estimativa de preço para você, tá? Então, quem tiver interesse, vou deixar aqui o meu contato.
Right, thank you. We'll just copy your email and then I will get in contact with you.
Sure. Any more questions? Mais perguntas? Acho que todo mundo entendeu tudo. Que bom. A apresentação realmente foi muito boa. Então, antes da gente terminar, né, encerrar esse webinar, e também para dar mais espaço, caso surja mais perguntas, eu vou colocar aqui uma enquete e eu peço por gentileza para vocês responderem, né, que é algumas perguntas sobre a apresentação. So, Christoph, I'm gonna put here like a survey for the people that are here to answer, and in the meanwhile, they're going to think about the questions.
All right.
So, Veridiana is congratulating you. She said that it was a very good presentation, it was very clear and objective.
Thank you very much. I'd love to hear that.
Então, para as pessoas do Brasil que estão aqui assistindo, né, agora a Nova Analítica está representando a Cytena, então podem ficar à vontade de entrar em contato conosco para saber sobre o orçamento, mais informações sobre os produtos, nós estamos aqui à disposição para atender vocês. Mi español no es muy bueno. So, yeah. Maybe we can check with Tabata if you can arrange some webinar in Spanish. Oh, so Tabata wants to say something. Let me release your audio.
Yeah, so the question, could I use the system to work with plant viruses? Sure. I mean, the material is not having any effect on the reaction itself. So once you have the virus in solution and buffer, you can work with any virus, of course. This is not, so the devices itself do not care basically which type of material they're dealing with.
Ok. Estão me ouvindo?
Sim, Tabata, estamos te ouvindo.
Ok. So, para as pessoas que não são de Brasil, acá em Brasil temos Nova Analítica representando a marca Cytena. En Argentina tenemos el distribuidor ETC Internacional y en Chile tenemos el distribuidor Gene Express y ellos pueden darle el soporte que necesitan. Yo también voy a poner mi correo acá en el chat. Si tienen alguna duda o si quieren este contacto, pueden escribir a mí, que yo les pondré en contacto con los distribuidores de su país. Y este es el primer webinar que tenemos, ¿no? Porque empezamos toda esta operación en Latinoamérica en diciembre del año pasado, entonces nosotros nos estamos, como se dice, estructurando. Entonces, sí, la idea es tener más webinars. No sé si vamos a tener en español muy pronto, pero puede ser que tenemos más en inglés, pero también enfocado en sus mercados, se fue la idea. Pero claro que con el pasar del tiempo, mismo los distribuidores, la idea es que ellos tienen todo lo conocimiento para poder ayudarlos, ¿no? Entonces, este es un proceso, pero ya estamos operando en toda Latinoamérica y después, entonces, si quieren, pueden entrar en contacto y podemos hablar más acerca de los productos, ¿sí? E para os brasileiros, eu queria agradecer a participação de todos. I want to thank Christoph, too, e a Maiara e Nova Analítica por essa parceria. E eu também estou à disposição para qualquer informação que vocês necessitem, junto com a Nova Analítica, que a nossa ideia realmente é trazer essas tecnologias agora para o Brasil, para a América Latina, e ajudar na pesquisa de todos. Tá bom? Obrigada, Maiara, thank you, Christoph, e obrigada a todos que participaram.
Perfeito, Tabata. Muito obrigada, graças. And thank you, Christoph, for your availability. And as a lot of people said, the presentation was very good, very clear. And so, se vocês tiverem alguma dúvida, fiquem à vontade para entrar em contato. A Tabata já colocou aqui o e-mail dela também, né, para quem for dos outros países. E acho que podemos finalizar. So, Christoph, we are going to end the session. E muito obrigada a todos que participaram. Espero que vocês tenham gostado. Tchau, tchau.
Thank you. Bye.
Adiós.